Good morning. It's a beautiful day in the data neighborhood. Nice spring day coming up here. Mother's Day in the United States and other parts around the world. So we're going to get into some content this week, discussing the foundations of data science and big data analytics, and we've got an actual research paper to write this week. It's about a great example of how and why big data and data in general is becoming so important. So we will uh, talk about big data a little bit and data analytics in general. I I understand, having been a database developer and kind of watching the world of big data um, happen. I understand the textbook definition of big data, but there's no fine line, so it's really hard to go from, in my mind, from just data analysis, which we've been doing, and big data analysis, which is where it starts to get kind of fuzzy. Um, so anyway, I know one of you is a big data developer. I'm trying to um, figure out a time to do an interview because I am not a big data developer. So I would love to hear um, more about those platforms and how you address business questions or research questions and get that answer back any differently than you would in a normal research project. So hopefully we'll make that happen. All right. So yeah, and then I'll go over the week 2 writing assignment, a couple of tips, and we will conclude. Classically, yeah, this is going back, early 2000s. The three V's of big data that um, that differentiate. Um, it's not a clear and bright line, as we say. It's a continuum from traditional structured, moderate sized data to just a data lake, a data ocean. So we got volume, variety, and velocity. Volume is being driven by the number of generators, right, and the size of files that are coming out. Video used to, um, you know, when I got my first computer, you really didn't do video editing. That was being done on like a Sun Spark workstation. You know what I mean? A specialized workstation, um, and it was highly specialized. There were some video editing going on, like on an Apple, but now we've got just videos and um, uh, smaller file sizes, but increasing number of generators because you've got like a third of all iPhone users wear an iPhone watch. I think I saw that here recently. Everyone has a smartphone in their pocket. I can't remember. It's been a little while since I Googled it, but how many billions of smartphone users are there on the planet, and how many billions of applications are there now? Um, Everyone is constantly looking at their smartphone, and think about that on a global scale. Um, and then the amount of data that generates, um, to be used on or not. The variety of data. It's from social media posts to video data to weather data. Uh, environmental environmental. We constantly put up more and more sensors, and there's satellites in orbit, and you've got different data formats, different data types themselves. Um, uh, yeah, coming at in a variety of formats. So think about think about what just what Google um, can offer in their different formats. They've got social media posts, they've got sentiment analysis you could do on YouTube. There's the Google Maps data, including topographical data, and the Google Maps car that drives around. Now you've got images that you can uh, um, analyze. You could, in theory, and maybe in practice, you could ask, how many red Ford pickup trucks did you see in a given geographical area and a given time window? I mean, you could go to the DMV, the Department of Motor Vehicles, and you could check to see how many are registered. But the Google Street View car produces data. I mean, those images are data that can be analyzed, but it's not traditional, and it's got to be moved in with the location data, which angle the car was pointed at. There's metadata um, for the car driving around, can be combined with satellite data. So there's just a enormous variety and velocity. The, the It's coming at enterprises so fast, particularly like the Amazons and WalMarts of the world, or governments that are tasked with keeping us all safe. Um, the, the the new data is what velocity stands for. And no uh, no big spoiler here. We keep adding V's. I think the the 7V model, because I know 5 leaves out one or two, depending on which 5V model you look at. But there are more V's um, that describe big data that we'll talk about in future weeks. Um, so yeah, so many, um, so many generators, sources of you've got police body cam video now that can be analyzed. Um, anyway, yeah, there's your volume, uh, and we are finding places to put it. Um, I don't know if any some of these um, newer um, newer tech um, storage technologies are going to help or not. It seems that we are actually able to store all this stuff. But anyway, it's up to, I don't know, 2,500 petabytes a day. Anyway, yeah, 2.5 quintillion bytes a day. It's an estimate I saw recently. And here we go, your variety. Like I said, you still have lots of structured data going on, because all that, the metadata behind social media posts, the likes and what you watched and how long you watched it for and who your friends are, that's all structured, highly structured. Um, Now, comments, raw text, aren't particularly well structured. Then you've got semi-structured tag data. Um, these are really useful, and you can throw these up into a NoSQL database, and the tags become basically the schema, the structure of the database, allowing you to quickly get meaningful answers out of that XML and JSON style data. You got, quasi-structured data that's got a lot of problems with it, that can be cleaned up. I know it's a large part of your data analysis effort. And then you've got unstructured, like Wikipedia pages. Well, yeah, and those are semi-structured, but the text within them, let call it a book. The content of a book, or the content of an image or a video, isn't structured. You need to comb through it with some sort of objective, and using some sort of tool to pull structure out of it, to pull information out of it. Okay. And of course, velocity. And this next this next slide, I wish they'd do a new one. I haven't seen an update to this in a while, but this next slide here, um, is an infographic. If you go to this, in the lower right corner, raconteur, which I believe is French for like a storyteller. They did this infographic, and it's still really useful. And these are individual, um, um, examples of why we have this big data phenomenon. Almost 4 billion. I assume it's over that now. This slide's probably 3 or 4 years old. 4 billion email users, and all of that email is data. Now, corporate emails, um, are not are useful to that corporation, because in theory, um, if it's like a private exchange server, then no one legitimately has access to any of that. However, if you're using a Yahoo Mail or Hotmail, apparently Hotmail is still a thing, um, or particularly Google Gmail, um, that stuff's being mined. That you're the metadata, particularly who sent a message to whom, when, how often, all of that sort of stuff. But even like keyword stuff is being mined. You get a confirmation email, from Travelocity, through Gmail, and it winds up on your Google Calendar. That hotel reservation will be on your Google Calendar. Uh, there's crosstalk going on there somehow. Anyway, yeah, like wearable devices, we got the iWatch, or um, smartwatch, in the lower right corner, 28 petabytes. Um, 463 exabytes. I remember when I learned what a gigabyte was, and it was in like single digits. Somebody ordered a 1 gigabyte hard drive, um, at work. I remember in like 1992, and we were all like, "What are you doing? A gigabyte? How are you ever going to need that much drive? You're an idiot." So there you go. That's pretty good depiction of the situation. And like I said, if you go to this raconteur, a day in data, you can pull this up and zoom into it. So I wanted to talk a little bit about data science in general. I love this Venn diagram. The data scientist Venn diagram. And I can't remember where I found this. I'm sure you can Google it. Um, there are four traits up here in the at the top of the screen here: communication, statistics, programming, and business or domain knowledge. Right. So this this Venn diagram looks at the intersection of these four factors. these four skill areas that a data scientist um, should have, according to the author of this Venn diagram. And I agree. If you're doing research, you got to have communication, because if you're doing research and not sharing it effectively with decision makers, you're only part of the solution. You are not a full service data scientist. And then you've got knowledge of statistics. You've got to have and this is one of my weakest backgrounds. You've got to have a knowledge of descriptive and inferential statistics and machine learning algorithms, and so if you don't, and you are getting into this line of work, um, probably best to go back. I'm tempted to take a college course, but so far I had Stats 101 as an undergrad, and quantitative research methods in my doctoral program. But I'm not strong on it. I need to probably go back and get some formal um, reskilling, upskilling, and then hacking, programming. There are too many tools out there um, for you not for you to be a data scientist and not be constantly coding, and or at least using applications, which is still kind of like programming. But anyway, and then over here on the right, you got business domain expertise, which is true. If you are just a generic nerd and the math and programming, but you don't know anything about the world, you won't be as useful as someone who is paying attention within their business domain. Okay, so these are, and there's a brief slide on it next. These are kind of the characteristics of a data scientist. Um, but what I love is the way the author um, uh, describes the intersection uh, of these traits. Particularly, look at this. Hopefully, you see the humor in this. If you have business domain and communication, but none of the technical skills, you are the salesperson. And if you have just communication and none of the other three, it's hot air. It's hot air is um, otherwise known as BS. If you have business domain knowledge, if you're a good business person, but none of the other three, you're an accountant, see number cruncher, analyst, salesperson. But then if you're a stats person only, you're a data nerd, but you can't communicate and you don't know any programming. So um, here at the intersection of all four is where you see the perfect data scientist. The uh, the head of IT, your CIO, doesn't have any statistical background, not a mathematician, but they can communicate and they know about programming, and they have domain knowledge. See that? I love the intersection of business and programming is the IT guy. I love this chart. Anyway, food for thought. So, data scientist traits. Yeah, here we go. Mathematical, hacking, and business. Um, gotta have all three. And this is from datajobs.com. That's where data science comes into the middle, or is at the intersection of um, those skills. Okay, and then uh, once you have skills and traits and everything, you've got to talk about um, the data analytics lifecycle. And I got this from um, VoxDigital.com. And there's also, well, if you just look, data analytics lifecycle, just Google it. There's so many resources out there. Um, but notice at the top, this is a typical cyclical, iterative life cycle process, just like the software systems development life cycle, you know, where you have phases, but you always can back up, between one and the other. They can feed each other. But you always, much like a software development effort, you start with your objective, which is in an analytics lifecycle, it's the business question or set of questions. What do we want to know? What do you want to know? Because sometimes you'll hear people telling you, well, what's the data tell us? Well, it tells us a lot. What do you want to know? What do you want to know? Um, so that's critical to starting. All data analytics efforts, all data science efforts start with an objective to answer some form of question. Now, this isn't talking about pure research that is developing methodologies that can be used across a spectrum of problems. This is talking about a particular data analytics effort. So once you've got your objective, then you move on to understanding the data, and this is looking at what data sheds light on that question. Not all data will be pertinent to every analysis effort, and it's really important that you don't get overwhelmed in a sea of data, um, which leads to the next step, which is cleaning and transformation. Transformation can be from one type to another. You got to get rid of null values and blank lines and headers and whatnot, and you can always transform. That's when you'll do your calculated fields like rates and ratios and whatnot. Um, uh, uh, and then through the data enhancement process, and then once you have the data clean, transformed, and you've gone out and enhanced the data with additional measurements. You go into your actual analytics phase, which is where you run the numbers. You have decided on your model. You've decided on how on what you're measuring and what's important in the business objective, and you actually run the analytics, and then you've got to publish the results, or it's all for nothing, right? So data visualization is where you actually do the storytelling, um, and show the results. A lot of times, um, these are done in different types of charts. There's a whole discipline. We'll talk about data visualization out there in about a week. I don't know, 4, 5, 6. So there's a whole art by people like Edward Tufte and Gestalt principles, where where humans see, we're visual learners. So there are things, proportion and contrast and factors that come into play when you're doing a good data visualization. And then we have a maturity model for data analytics, just like you've heard of the software capability maturity model and all these other different maturity models. The first one I was ever uh, introduced to was um, the uh, software capability maturity model. We were one of the earlier people, I think, getting it back in the late '80s, early '90s. Folks from Carnegie Mellon University in Pittsburgh came out, and I was in a level one software organization, totally ad hoc. I mean, it wasn't a tiny software organization. We had 25 programmers, give or take, but we were definitely not optimizing. So this data analytics maturity model is similar, in that it goes from hindsight to foresight, which is looking backwards to looking forward. So descriptive analytics are just tell you what what occurred in the past. What were our, say, our sales figures from last quarter? And then you start to look at, diagnostic. Well, you start looking, well, why did that happen in the past? And you can look at things like, well, there was a change in the season. You can look at, seasonality of your data, or maybe we spent more money on advertising. And you can look at, return on investment. Every time we pump an additional $10 million into advertising, we get an additional, $15 million in sales, say. So then predict, and this is where, and then right in the middle there, it starts to get tougher. What will happen? You can use past data to predict what will happen in the future, but it gets complicated because there are often multiple interrelated factors that predict the future. That's why, you know, we don't have just, what's the stock market going to do tomorrow? And you click a button. I mean, if it was easy, we'd all be doing it. It would be out there. So predictive and then prescriptive analytics, these get to be more art, where you're looking at things and you're making, um, what would you call it, best guesses based on data. That based on the information, um, but then you've got to have some intuition, the ability to, to understand human beings and trends, and see what might happen in the future, or how can we make it happen. Um, so yeah, these first two are pretty straightforward, but then it gets more and more difficult, and that's why more organizations, see on the difficulty scale down here, are on the lower end, because as the value goes up, the difficulty gets harder. So there you go. So some of you in your introduction, I could tell where you're at professionally. Others, I could not. Uh, you introduced yourself, and I don't really know what you do. I posted my resume in the My Instructor link, so you can see um, what all I've done, or at least the roles I've had. Um, so as we've said, data analytics teams, every data science project starts with a question. So we've got to make sure going into that project, going into that cycle, that we have key roles addressed. And there are a lot of folks involved in a data analysis project, but typically a large one in a large organization. So let's talk about these. Your business user is the person that's not an analyst necessarily, not a data scientist, not even an IT person, but they've got the um, the business problem. It could be, somebody that's in manufacturing, and they're seeing too many defects, or it could be somebody in sales and they want to optimize sales. It could be somebody in finance and they want to identify trends in funding and things like that. So yeah, your business user is the person with the domain expertise and the domain problem. Okay. And remember, these are team roles. So I'm curious if maybe you've been in a project that didn't have these roles, and maybe saw where you might have needed them. Anyway, so then you've got your project sponsor. This is your decision maker, that has some influence, some power, and will be able to possibly redirect resources and clarify priorities for you. as opposed to the project manager, which is somebody that's just making sure that the process is being followed, and that key steps and meetings and validation steps and things like that are being addressed. Like a software project manager is not normally the leader. They're tracking things, but they're not a decision maker necessarily. Another key role is a business information, business intelligence. I'm sorry, business intelligence analyst. This is a lot of times this is the person that's really good on Tableau or Power BI that will operationalize the results of the analysis, and get it out there on a dashboard or in key visualization steps. DBA is a database administrator. This is a person that makes sure the database is up and running and backed up. Can help with uh, key roles and query optimization and all the kind of the guts of what's going on inside of a database, whether it's MongoDB or Oracle or whatever. The database administrator is um, making sure that internally that works. Data engineer, you're starting to see a lot more of this, and people are I think, corporations are starting to understand what a data engineer is. That this person's really um, responsible for moving data around more than the DBAs, kind of, and I think a lot of DBAs have moved into being a data engineer. So there's no fine line here, but data engineering is really more about making sure that the right data is in the right place and that processes are automated in order to refresh. You see a lot of data engineering in automating the refresh of a data warehouse, which we'll talk more about uh, in future weeks. But yeah, data engineers is moving data around and helping to automate and make sure that that process is done um, uh, with quality and repeatability and confidence. And of course, your data scientist. This is an overused term. A lot of folks just doing plain old analytics. Um, are calling themselves data scientists. So it to me, month to month, year to year, the term is being watered down. But to me, this is the person that's extending the frontier. This is the person that's developing new methodologies, testing those methodologies to see if they're an improvement over previous methodologies. And that's, this is in the field of like um, artificial intelligence and machine learning algorithms and image recognition software and stuff like that, where they're pushing the frontiers and they have the background, the experience and education to say that a certain model will give the best results, and that can be as simple as choosing the right uh, statistical measure, like a t-test versus Pearson's R, or chi-square test. Those, all those sorts of statistical tests. Um, uh, they have the the background to make sure that the project is being done using the right approach. But again, they're part of it. So that's kind of intro to the whole data science world. Um, and this week, we do have a paper due. So you will see this graphic in the classroom, and it talks about all the different uh, things that can go into um, making a city smart or not. And different cities do it with different levels of intensity and investment. Costs a lot of money. Takes a lot of infrastructure. So you've got, uh, the art, the link I posted is not an academic journal article reference, but it's a good place to start to learn about what's going on in smart cities. Some of the biggest ones that you'll see that you'll read about are in traffic management, where they start to measure demand and open lanes appropriately based on the data, not um not what you think is going on, but what the data actually shows you. Traffic management, definitely smart energy, where you have programmable thermostats. That as it could be as little as that, but it gets uh, more into um, they're making buildings now with photoreactive windows, that turn darker as the sun hit so they don't so they cool more. Um, from that to the smart energy grid, redirecting power to where it is needed during the right time of day, uh, clicking over from wind to solar during the day and back to wind at night, or back to conventional power at night. You've got sensors all over the place. Your parking lot is seeing cars come and go. It goes click every time somebody comes in. It goes click every time somebody goes out. Um, so you have in parking garages, you have some level of intelligence of demand and supply and demand. Um, but there's just so much going on. You got gunshot detectors out there, traffic cameras, security cameras, um, uh, applications, smart applications. Um, so anyway, lots and lots and lots of applications of smart city technologies, which we will get into in this week's paper. So I have modified the instructions in this um, lecture, but I did not modify them online. So what I'm doing is, if you're listening to this lecture, I'm giving you um, less restriction. It should make it easier to write, I'm thinking. So here's the instructions. Uh, they want you to the university instructions are to write about this radical platform, which there's a few articles out there. You can find these, but I've extended it to be just plain old smart city applications. You don't have to limit your paper to this radical platform as described in the mandatory article reading article. There are, if you go to Google Scholar and look up smart city, you'll find lots more out there, or just plain old smart city applications. Okay, now one thing that should have confused you in these instructions is including how big data analytics is used in those situations, as well as with smart cities. I put this question mark in there because that's what we're talking about. We're talking about smart cities. So why are they making it sound like it's two different things? It's not. So anyway, and this is coming from the university. Everybody in ITS 836 gets told, be sure to use um, the library for scholarly research. Google Scholar is the second best option. I disagree. I start with Google Scholar, and if I can't find a full text article, I move over to the library. I always start with Google Scholar. Okay, some pointers on that paper. Um, 2-3 pages in length, no table of contents, and no abstract. Okay, but I do want a separate cover page and a separate reference page. Okay, so when I see a student paper with no page break before the references, I gotta wonder what you were thinking, because I've given you a template. and use APA section headings, bold letters. Okay. Okay. Support your response to the instructions with readings from the course and at least 3 peer-reviewed articles. Okay. I always start with Google Scholar. See, this is coming from me. um, be clear with well written, concise prose, excellent grammar, and style techniques. Um, oh, that is not accurate. Uh, but textbooks are, just as a background point, textbooks are a great source for defining a term, defining a word. Okay. So, in conclusion, here at the beginning of week 2, um, you will see, like we talked about back in the roles in a data analysis team, there are lots of overlapping terminology here: data science, analysis, analytics, statistics, business intelligence, data mining, machine learning, artificial intelligence, big data, structured data. There's just a lot of related in terms, and there's uh, often not a fine line between them. Um, so, uh, and that's okay. It's an emerging profession. It's not as old as some other professions. There's no, like, the medical profession has the American Medical Association. I don't believe there's an American Data Science Association that has the same rigor as the AMA. So we're still sorting it out. So yeah, smart cities are an excellent example to study big data applications. You've got, folks walking around on, doing, on social media, they're ordering food and they're ordering scooters and they're rating things. They're making appointments in places. I mean, there's just so much data within a smart city. And like I said, I included an article to Singapore, which, if you're unfamiliar, Singapore is like almost an island city state country. So yeah, they've got unique challenges, but also unique um, in that it's small. It's not anywhere near, the geographic size and population of, a China or an India or a Brazil or United States. Um, so they can approach things with a lot more control. But anyway, yeah, check out that article. It's a link I put along with that big infographic on smart cities and big data. So when you're writing, make sure you're focusing on the requirements. Um, I There will be something short in the instructions, and I read the paper expecting it to relate to that. I see the most time people getting in trouble when they're trying to reuse stuff they found online versus writing themselves. I saw a lot of hits on my Word EndNote demo video and my academic writing for systems engineers videos. So you know what I'm looking for. So now that I know, you know what I'm looking for. No fooling around. I'll be looking for stuff that's obviously original and using proper English terminology, not article spinner output. So, you have seen. No one has called anybody out really, but you have seen article spinner output in the classroom already. Just in that week 1 discussion about the 3F method, you saw people using terms that don't exist, and that's an article spinner. They don't understand um, things like colloquialisms, like I talked about in the introductory video, like a user group. That's a term. You don't mess with that. You don't reword that. And if by chance Grammarly is convincing you to use um, non-standard terms, because Grammarly does identify overused words, ignore it. Ignore Grammarly and the overused words if it's trying to get you to change something that is industry standard terminology. I don't run a Grammarly report on all of your writing. I read it. Uh, and if it makes sense and it flows and it uses proper terminology, and it addresses the requirements, it's an easy A. It's A. A papers are uh, are easy for me to grade. It's when I start seeing nonsense that I start having to highlight things and ask questions. When I see citations where the article you cited doesn't really have anything to do with what you're talking about, um, that's what I say. You've seen my word endnote demo. I gave you a good example of going out and you remember reading something and you want to cite the author that made that point. I think mine was about um, enterprise social media and uh, user impressions of it. I haven't watched that video myself in a little while, but I found a place in the article where they make that point, and that's why I cited it, because the author made that point as a fairly large part of their paper somewhere. So I expect the same from you guys. So I have included a sample student paper, an example student paper in APA 7 format. I'll pull that up real quick here. Stop sharing that. Um, pull up sample paper and share it. Okay, so what I'm looking for in your papers is a similar title page, um, your the title of your paper. Um, we indent paragraphs. I see PhD students that don't indent their paragraphs. I see it all the time, and it's inexplicable. So yeah, double space in paragraphs, um, and indent your paragraphs, and then this would be like your introduction, and then uh, you only I don't you're never going to need three level headings. Okay, so this would be an example of a first level heading. See, it's centered, and then your second level heading uh, um, is left justified, and then you go back to paragraph format. Another second level heading, paragraph format, and then another first level heading, number two, and then we go back to second level heading, and you see here the uh, APA format. If you're using bibliographic software, or at the very least a citation generator, you should be fine. And then yeah, and you don't need three sections, and there's no specific number of sections. These are just examples. And you don't have to use subheadings in your conclusion. But if you are, these are examples of how to do it. And then a separate references page. Put a page break between before your references section. Okay. And if you use this file as your template, it'll come out in the right format. But something like EndNote puts your references here and keeps them in. Notice their alphabetical order, and the first line is left justified, and then subsequent lines are indented. That is your appropriate APA format. Um, I'm not gonna scrutinize your references down to, like, the journal article being in italics and things like that. Bibliographic software does that automatically. So I encourage you to use it because doing your dissertation, whew, uh, I you know I'm out there on ProQuest. You're welcome to look me up. I had, I don't know, 120 references. I don't know, pages and pages. So maintaining them manually would have been um, difficult to say the least. All right, back to my PowerPoint because I wanted to make a couple more points. Yeah, use the template. Use it, please. Makes it more readable for me. Makes it easier for you. Okay, so last week I talked about being conversational in your discussion replies. You are going to start seeing in my replies within the discussion board. There are times when I have said, "Yeah, we all read the article." When you reply to someone like this 3F method, and all you do is say, "Good post. The 3F method has 3 steps." Blah 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 blah. We all read the article. Okay. Most of you in your introduction said that you're here. Your goal. You're here to learn. Okay. Well, don't waste each other's time by just spitting out basic facts from whatever the article is this week. Um, actually discuss it. You know, you understand that, right? You're discussing an issue, um, which means when I read your reply to the fellow student, I can tell that you are honestly talking to them and inviting discussion. You are encouraging them to reply to you. Now, some students do this, and all they do is they ask a question, but it's obvious that they're just filling the square. They're just asking a question that is unanswerable or whatever. You know what I mean? Make classroom discussions personal and valuable and authentic and real. Okay. Actually discuss these topics with each other. Don't just check the block. Because you'll see in my comments when I think you've replied with nonsense, And another thing I saw somebody post somebody else's reply as their reply in the same thread, and no one called them on it. No one said, "Hey, your reply looks just like this other guy's. What are you doing in here? What are you trying to do?" Hold each other accountable. Okay, when somebody posts something, and it'll happen, that isn't worthy of your time, you should let them know. It's way more effective than me. You'll learn more. Everybody said they're here to learn. You'll learn a lot more from honest feedback from your colleagues than you will from me, because I'll just be painted as the bad guy. Um, so yeah, if you guys really want to learn, then learn and show me you're learning by interacting uh, for real, authentically in these class discussions. Um, the more authentic they are, the more I see it, you guys being for real, the more I get in there. The more garbage I see in class discussion where you're just filling the square, you're just replying because that's what you got to get your 2 replies. So the more I see that sort of thing, the less engaged I become and the easier it is for me to hand out zeros. So there you go. Full disclosure, you need to know what I'm looking for, and I've been as clear as I can be as far as class discussions, and I'm seeing mixed results, which is frustrating for me. So that's what you're sensing. If you're sensing frustration in my voice, that's because I'm frustrated. that I'm unable to get consistently get students to treat these discussions professionally. So I'll keep working on it, and you keep working on it, and I will see you. It's Sunday. I'm going to wrap up discussions here a little bit. Um, but then we have a research paper this week. No discussion board. So I look forward to seeing your papers. All right. As always, I got one question this week. Somebody emailed me and said, "Hey, can you open up future weeks so I can see what's coming up?" And I was like, "Sure. Just make sure that your discussion posts are posted within the week where they're due. Don't do anything with a discussion board outside of the week where it's assigned." Other than that, I didn't get any questions about anything. So, including my invitation for you guys to shape your residency assignment. No one said a word about your residency assignment. So, okay. All right. Email me any questions or concerns, please. And that concludes our lecture for this week.